Hello, chemistry students. Welcome to class for today. And today, without wasting too much of your time, I will be going through everything we have covered this term. But I want to segment it so that the video will be easier for you to watch and to go through. I will review what we did for week 5, week 6, and week 7 today. If you remember very well that last week I sent out a link for the video, and that video covered week 8 and week 9, and the topic then was hydrocarbon. So we've actually covered everything that has to do with hydrocarbon. So for today I will cover carbon and its compound, and that topic spreads across week 5, week 6, and week 7. So let's get started. For week 5, this is what we have for week 5, and you will see the content for the topic there. Carbon and its compound. Number 1, we have carbon, the allotropes of carbon and their structures. Number 2, we have properties of carbon, differences between diamond and graphite. And then number 3, we have chemical properties of carbon. Number 4, we have coal and types of coal. So the first thing we want to consider is the occurrence of carbon. What are the forms in which carbon exists? Number 1, we have the uncombined form of carbon, which is diamond and graphite. Diamond and graphite, they are pure form of carbon, just carbon alone, no other element combined with it. And number 2, we have combined form of carbon. Carbon can be found in combined state as carbon dioxide, as natural gas, petroleum, wood. Number 3, carbon can be found in mineral deposits like calcium carbonate or limestone, and magnesium carbonate or dolomite. So those are the 3 forms or 3 states in which carbon exists. Then moving on, it is important for us to know the structure of carbon so that we can have a clear understanding of how carbon combine with other elements and the underlying principle behind the chemical properties of carbon and everything that has to do with carbon. So that's why we need to know the atomic structure of carbon. Carbon as an element has atomic number of 6. If you count from hydrogen, helium, to lithium, to beryllium, to boron, and then to carbon. So carbon is number 6 in the periodic table, and the atomic number is 6. That means that carbon has 6 electrons. Now, if you break that down to the electronic configuration of carbon, you will see that in the first shell, which is K shell, there are two electrons rather. There are 2 electrons there. And in the second shell of carbon, you have 4 electrons. Let me quickly show you the diagram. Yes, this is the diagram. So here, you will see here the nucleus. This is the nucleus. So the nucleus is made up mainly of protons and neutrons. So away from there, the first shell, this is the first shell here. This place is the first shell. That first shell, you will see 2 electrons there. So and then the second shell, you have 4 electrons. This is the first electron, this is second electron, this is the third electron, and this is the number 4 electron. So you have 4 electrons on the outermost shell of carbon, and this forms the basis of chemical combination of carbon with any other element. Please take note of that. You will need it when you begin to draw structures. Like in the last note I gave you on hydrocarbon, I draw some structures for you where carbon join with hydrogen and with carbon and with hydrogen and with carbon and with hydrogen. So is these four elements on the outermost shell of carbon that forms the basis for that combination. Please take note of that. Then let's move away from there and go back to the notes. So the notes now. Sorry. So okay, back to the note now. So we've talked about the structure of carbon, and because of this structure, carbon can join to carbon, to carbon, to carbon, to carbon, and form a very long straight chain or even branched chain through a process called catenation. You will see it there. This catenation, let me quickly show you here. This catenation, it's a catenation here. So that's the process whereby carbon join to carbon to carbon to carbon through covalent bond to form a continuous framework. So that's catenation. So let's go back to allotropes of carbon now. There are two major allotropes of carbon. You have crystalline form of carbon, crystalline allotropes of carbon, and non-crystalline or amorphous allotropes of carbon. When you say something is crystalline, it has definite shape. So when I say crystalline allotropes of carbon, they have definite shape. When I say amorphous, when you say something is amorphous, that means that it is shapeless. It has no definite shape. Those of you that did biology, you will remember when you say amoeba has no shape. So when you say somebody is an amoeba, that means I'm sorry to use that. Sorry about that. So let's just go on. So when you have crystalline form, it has a definite shape. When you have amorphous carbon, it has no definite shape. So example of crystalline form of carbon, we have a diamond, and then we have graphite. So you see the structure of diamond there. Diamond is the purest form of carbon you can ever get. Diamond is very pure. It's the purest form of carbon. And then you also have graphite. So you see the structure of diamond there is octaedral crystal. Octaedral. That's it. It has eight corners. So octaedral. And you have the another thing to note about diamond. Okay, let's just look at physical properties of diamond. One, pure diamond is hard, colorless and transparent. Then number two, forms octaedral crystal with high refractive index. Number three, it is very hard. It has a density of 3.5 gram per cm cube. And the melting point is 3600 degrees C, very high. Then diamond does not conduct electricity. The reason being that all the four valence electron that I told you of when I show you the structure, the electronic configuration of carbon, all those four outermost shell electrons, they have bonded with another carbon. So there is no mobile electron. There is no mobile electron on the outermost shell. So because of that, diamond cannot conduct electricity. Then number five, diamond is not soluble in any solvent and is very resistant to chemical attack. There is no amount of acid that you can pour on diamond that will destroy diamond. Very resistant, very stable. So let's go on. There we have what we call artificial diamond. You can make artificial diamond by converting graphite to diamond using nickel catalyst or rhodium catalyst and at a very high temperature and pressure. So, uses of diamond. I listed 4 uses of diamond there. Because it has high refractive index, it is used as jewelry. Number 2, because it is very hard, diamond is used for cutting glasses and for drilling rock. Now, let me tell you something. There is no any other thing that can cut diamond. It's only diamond that you can use to cut diamond, because diamond is very hard. There is the hardest known substance we can ever find, and because of that, you can only use diamond to cut diamond, but you cannot use any other element to cut diamond, and you can use diamond to cut any other element. I hope you understand that. Now, number 3, it is used as pivot support in precision instrument. And number 4, because it is dense and very hard, it is used as abrasive to sharpen very hard tools. So that's that about diamond. Let's go to graphite. Graphite is a black, slippery, and two-dimensional flat hexagonal crystal. That's it has 6 corners. In the case of diamond, it has 8 corners. We say diamond is octahedral, but graphite is hexagonal. It has 6 corners. Now, now graphite is arranged in layers. If you look at this diagram here, this graphite, you see the first layers. Let me show you. Let me quickly show you. You have first layer here. You see this. Okay. Don't let me use that. Let me use something else. Which one can I use now? Let me use. Okay. Let me use this. So this is the first layer. This is the first layer. Let me draw it very well so that you can see it very well. First layer, the one at the top, that's first layer. Then this is second layer. This is second layer here. This is second layer here. So that's second layer. So graphite is layered on top of like that. And because of that layer, they can slide over each other or one another. And that's why graphite is considered to be very slippery. They use graphite as a solid lubricant. Because of that slippery property of graphite. Okay, let's go on. So, properties of graphite now. I think I've explained that most of that. Number 1, graphite forms soft, black, and opaque, hexagonal. Then the softness is due to the ability of the adjacent layers to slide over one another. Then number 2, it is hard. Number 3, it is a good conductor of heat and electricity due to the presence of a mobile electron per carbon atom. Now, in diamond, there is no mobile electron. But in graphite, there is a mobile electron, just one. And because of that mobile electron, graphite can conduct electricity. Graphite is soluble in any solvent. So that's that about graphite. And then uses of graphite. Graphite, like I mentioned before, is used as lubricant because it's flat hexagonal layer which can slide over one another. Number 2, it is used as inert electrode during electrolysis. When you get to SS2, you understand that. Number 3, when mixed with clay, yes, you need to understand this. Graphite is used in making pencil. that pencil you used to draw in class is made up of graphite. It's made up of graphite. Now, it's usually mixed with clay. For those of you using 2B pencil, you will see that 2B pencil is hard and harder than HB pencil. It's because of the ratio, the proportion of clay to graphite in the pencil. So if you have high proportion of clay, you have hard pencil. If you have low proportion of clay, you have soft pencil. So number 4, graphite is used in making crucible, and number 5, it is used in nuclear reactor as a neutron moderator. So that table there shows you the differences between diamond and graphite. So you can go through the table after explaining all the points there in the table. So now let's go to amorphous carbon and types of coal. Amorphous carbon, like I told you before, they don't have definite shape. Amorphous don't have definite shape. So example, we have number 1, you have charcoal. Okay, let me just give you a general example now. You have coal, you have charcoal, and then I think there is one, and coke. Coal, charcoal, and coke. Those 3 are examples of amorphous carbon. Let's take the first one, which is charcoal. There are different kind of charcoal. We have a wood charcoal. You make wood charcoal from wood. When you burn wood in limited supply of oxygen, it will produce one black substance like this. So that is wood charcoal. Number 2, we have animal charcoal. When you burn the bone of animal in limited supply of oxygen, it will give you animal charcoal. And you use animal charcoal, for decolorizing crude sugar and petroleum jelly. And number 3, you have sugar charcoal. Sugar charcoal is made from the dehydration of glucose. Here is you see this is the equation here. This is the equation. Let me quickly show you. This is the equation. So you see this equation here. This equation here. Yeah, this equation here. So that's this particular this sugar. This one I highlight is sugar. And when you use concentrated H2SO4 to dehydrate it, you remove molecule of water. You remove 6 molecule of water, and then it will give you 6 carbon, and that one is what we call sugar charcoal. Please take note of that. So let's move on. Then another one is soot or carbon black. So you can read the note for details and to understand better. So now let's go to coal and types of coal. Coal is made from rock formed from the vegetation of the, it's a kind of a story, from the vegetation of the Carboniferous period. What happened basically is that when you have wood, organic substances like wood, if you go to a forest, you will see wood, thick wood now. When they are buried under the earth for a long period of time, they transform. There is a kind of chemical transformation in this wood to form coal. So that's a simpler explanation of that. So you have different types of coal. You have peat, lignite, bituminous, anthracite, depending on the percentage of carbon in them. So the hardest form of coal is anthracite with 94% of carbon. while the softest is peat coal with just 60% of carbon. So that's that about coal. So you have carbonization of coal. That's the first stage in the conversion of plant material into coal. And then we have a rank of coal. It's the arrangement of coal. So I give the arrangement there from peat to lignite to bituminous to anthracite. And then we have uses of coal. Just read the note, you will see the uses of coal there. So let's go to destructive distillation of coal. In destructive distillation of coal, what you do is just to heat coal to a very high temperature, and it will dissolve. It will break to its constituents. So when you break coal, it will give you four major constituents. Number one is coal gas, number two is coal tar, number three is ammoniacal liquor, and number four is coke. So that's what you get when you break down coal. That's the meaning of destructive distillation. It's not that you destroy it. Well, you destroy it in a way, but it will give you some other useful products. So that's a destructive distillation of coal. So let's go on. So you see the diagram here. This is a diagram for destructive distillation of coal. This is the diagram. You can draw it in your note if you prefer. So, um, so you see the uses of the different uses of the product of destructive distillation of coal: coal gas, coal tar, ammoniacal liquor, and coke. So you see their uses in the notes. Please go through the note, please. Now, uses of coke. So you see the uses of coke here. Gasification of coke. Gasification of coke is the conversion of coke to combustible gases by incomplete oxidation with steam and air. Partial oxidation of coke with air gives producer gas, and partial oxidation of coke with steam gives water gas. Now, try to understand this. We have when you gasify coke, that is when you change coke is solid and you convert it to gas. It will give you two different products depending on how you convert it. If you use pure air as in normal air that we're breathing, if you use that air to gasify coke, okay, let me quickly show you the equation here. Now, this is the equation here. This is the equation. Hold on. This is the equation here. Yeah, that's the equation for gasification using air. The air here is oxygen. Okay, let me quickly do this. Let me magnify it a bit so that you can see. Okay, let's go back to this. So let's say you use this equation. Let's say now this is oxygen. So you use oxygen to gasify. Inside air, there are three major gases there. You have oxygen, you have nitrogen, you have carbon dioxide. So that's why here you see O2 and N2. That's oxygen and nitrogen. And you see the coke itself. This is a coke here. Where you see 2C, that's a coke. And then it will give you N2 plus CO2. Sorry, CO, I'm sorry, not CO2, CO and it. You see those three things. So producer gas is a combination of nitrogen and carbon monoxide, carbon 2 oxide. Just two compounds, or two constituents rather. Let's use the word constituent. So you have nitrogen and carbon 2 oxide are the two constituents of producer gas. Now let's go to water gas. This water gas here, this water gas here, this water gas. This is the equation for water gas. If you use steam, that's liquid H2SO4. Liquid H2O. If you use liquid H2O, this liquid H2O here, to gasify coke, to gasify coke. You see C plus H2O. So it give you CO plus H2. So water gas is a combination of hydrogen and carbon monoxide, while producer gas is a combination of nitrogen and carbon monoxide. So please take note of that. That's the difference between producer gas and water gas. So let's go on. So that's the end for week 5. Week 5. That's the end of week 5. So let me quickly go to week 6. Or where's week 6 now? Let me quickly go to week 6. Okay. Sorry. Okay, let's go to week 6. Yeah, this week 6 good. So in week 6, we talk about the properties of carbon. Number 1, combustion reaction. So carbon, when I say carbon, I've told you the differences, different state of carbon, the different forms in which carbon exists. So when I say carbon, you know what we are talking about now. So let's take carbon. The chemical symbol for carbon is C. So the properties now, carbon will bond with oxygen in limited supply. When you put small oxygen to combine with carbon, it will give you what? It will give you carbon monoxide. That's carbon 2 oxide. If you now put excess, plenty here to carbon, it will give you carbon dioxide or carbon 4 oxide. Please take note of that. Number 2, combination reaction. You see the different equation I give there. Number 3, as reducing agent. Carbon is a reducing agent. It will reduce another compound, while itself will increase. So in this equation here, let me quickly show you this equation. In this equation here, carbon is reducing Fe2O3. You will see that there are how many oxygen do you have with Fe there? You have three atoms of oxygen. But when carbon reduces it reduces to Fe with no oxygen again. Why carbon itself now has one oxygen? That means that carbon has increased, while ion has reduced. So carbon reduces ion 3 oxide to ion, and carbon increases itself from carbon to carbon 2 oxide. Please take note of that. And then number 4, reaction with strong oxidizing agents. So I give you an equation there. Please take note of that as well. So those are the properties of carbon. Now let's go to carbon dioxide. Carbon dioxide now. We are looking at the different compounds of carbon now. Different compounds of carbon. We will start with carbon dioxide. Number laboratory. There are different ways of preparing carbon dioxide. The first way is what you have represented by these equations. You see these 3 equations here, they represent a single way of preparing carbon dioxide. Now let me zoom it. Let me zoom it so that you can see better now. Let me quickly zoom it. Let me zoom it here. So here, action of dilute hydrochloric acid. That's the first one. The first one. The first one here. Sorry. Let me use another. Let me use this one. So this is the first one. This is the second one. This is the third one. In the first one, you have action of dilute hydrochloric acid reacting with calcium carbonate. This calcium carbonate, it will give you calcium chloride, water, and carbon dioxide or carbon dioxide. Please take note of that. So in the second one, this second one here, dilute HNO3. This is dilute HNO3. This one is dilute HNO3. Reacting with calcium carbonate. This calcium carbonate to give you calcium nitrate and liquid water and carbon dioxide. This is carbon dioxide there. This is it. So, and then the fourth equation there, this is the third equation. The third equation, you also see how the equation goes. So, but in all of them produce carbon dioxide, and carbon dioxide. So all of them produce carbon dioxide. Please take note of that. Then number 2 way, the second method of preparing carbon dioxide, you have okay, I actually put it as number 1 here. I number it as 1, but it's the second method actually. So this one, complete combustion of hydrocarbon. You see the equation there. And another method is decomposition of triisocarbonate 4 salt. When you say something decompose, that means that it breaks into its constituent parts. So you see the decomposition here. This is the decomposition. This decomposition. You see it. When calcium carbonate decomposes, it gives you calcium oxide. Let me draw that again. It gives you calcium oxide. That's calcium oxide or quicklime, and carbon dioxide and carbon dioxide. So all thiazocarbonate 4 salt will decompose to give you carbon dioxide. And then the last method now is fermentation of glucose. Fermentation of glucose by enzyme. The name of the enzyme is zymase. So when glucose ferments, this is the equation here. So this one is glucose. This one here is glucose. I hope you are following. Sorry. So and this one here, This one here is called ethanol. Ethanol, popularly known as ogogoro. So, and then this one here is carbon dioxide. So, or carbon dioxide. So that's another way of preparing carbon dioxide. So let's go on to the physical properties of carbon dioxide. It is a colorless and odorless gas. 2. It does not support combustion. 3. It is heavier or denser than air. 4. It is weak acid, which turn most blue litmus paper red. Acid will always turn most blue litmus paper red. So when you say you have a gas that turn most litmus paper from blue to red, you should suspect carbon dioxide. Then it can be readily liquefied and solidified. So to form dry ice, So you make dry ice from carbon dioxide or carbon dioxide. So let's look at the chemical properties. Let's look at the chemical properties of carbon dioxide. The first one is it dissolves in water to give triisocarbonate 4 acid. You see the equation there, H2O plus CO2 will give you H2CO3. So that H2CO3 is called triisocarbonate 4 acid. So in other words, CO2 is an acid anhydride of H2CO3. So number 2, it neutralizes the base that is sodium hydroxide NaOH or potassium hydroxide KOH to give salt and water only. So you see the equation there. This is the equation. This is the equation. So that's the equation there. CO2 plus NaOH will give you Na2CO3 plus H2O. That reaction is called a neutralization reaction. The CO2 is acting as acid, NaOH is the base, and it will give you the salt there is Na2CO3 and water, H2O. So when you have excess of CO2 now, as in this case here, the end result will be NaHCO3. So that's what we have in this cycle that I just draw here. So let's go on. Number 3, it is an oxidizing agent. So it will oxidize another compound, but it itself will be reduced. So here in this equation here, this equation, now you see CO2 there, CO2, this is CO2 oxidizing carbon to carbon monoxide, but CO2 is reduced. So, and the same equation for Mg plus CO2 giving you MgO plus C. So, that is the reaction. So, let's go on to the next one. Now, number 4, it reacts with lime water to form calcium. Oh, sorry, there is a mistake in this equation, in this statement rather. Lime water is calcium hydroxide. That CaOH2 is lime water, it's called lime water. Let me show you very well. This one here, this compound CaOH2 is lime water. So it will react with that lime water to give you calcium carbonate. This calcium carbonate here. But if you now pass, now this calcium carbonate that I just draw here is called, is milky. It's like, it looks like milk, But if you now pass excess of CO2 into it, it will give you CaOH, CaH, CO3, CaH, CO3, and this one is colorless. This CaH, CO3 is colorless. Now this equation that I draw here, everything here is what you use to test for the presence of carbon dioxide in the laboratory. Please take note of that equation. When you pass limited quantity of CO2 into CaOH2, it will give you calcium carbonate, which is milky. But if you now pass excess, that's the second equation now. This is the second equation. The second equation, if you pass excess of the carbon dioxide, it will turn colorless. And what makes it to be colorless is the presence of the compound Ca into bracket ACO3 into bracket 2. So please take note of that. Uses of carbon dioxide. Number one, it is used as fire extinguisher. It's used to like if a house is burning or a house is about to burn, you see all these cylinders, small red cylinders. Oh, I don't know if you have seen that before. We have small red cylinders that station a strategic place in a building. They are called fire extinguisher. So if there is going to be a fire outbreak, I just carry that thing, you uncork it and you spray it to the fire. There was about there was about to be a fire outbreak in our lecture hall, and we have that in our lecture hall. So we just carry it, we uncork it, we open it, and we spray it to the fire, and the fire died down. So we use carbon. That's the content, the inside that cylinder you have carbon dioxide. So when you just spray it to fire, the fire will die down. And the reason is because carbon dioxide is heavier than air and it does not support combustion. So number two is it is used in production of aerated drinks such as Coca-Cola, 7-Up, Pepsi, and so on and so forth. Number three, it is used as effervescence in certain earth salts such as androliver salts and so on and so forth. Number four, it is mixed with tartaric acid and used to as baking powder. Baking powder is made up of NaCO3. So number five, it is used in the production of Na2CO3 by solvent process. Number six, it is used for photosynthesis. Now, those of you that have been doing biology, you will remember photosynthesis. So it's carbon dioxide that is used in photosynthesis to produce the food we eat. And then number seven, solid CO2 is used in dry ice. So dry ice is made up of CO2, liquid, solid CO2. So that's that about the class for week 7. And let's quickly go to week 8 before we round off this session. So in week 8, we talk about carbon 2 oxide. In week 6, we talk about carbon 4 oxide. In week 7, we talk about carbon 2 oxide. Production of carbon, laboratory preparation of carbon 2 oxide. There are 3 methods there. Number one is dehydration of methanoic or formic acid. Dehydration of formic or methanoic acid using concentrated H2SO4. Now, I told you that dehydration is the removal of water. Removal of water is called dehydration. If you look at this now, this dehydration, removal of water. H2SO4 removes water. That's why I put minus in front of H2. So that minus is representing removal. So this one here, This is formic acid. Now, if you remove H2O, you will see that how many H do you see there? There are two H and there are two O. So if you remove two H and one O, it will remain uh, CO. So that's why you have this CO. So that's number one method. Then number two method is dehydration of ethylene acid or oxalic acid. You call it ethylene or oxalic acid. Now this oxalic acid there, this oxalic acid there. So when you dehydrate this oxalic acid, when you remove water, if you remove this let me magnify it a bit more. Let me quickly magnify it a bit more. Now look at this compound there. And so if you remove this H, remove this H, and you remove this H2, and then it's H2 you want to remove, and then you remove the O. Let's say this O. You remove this O. So what do you have? You have this CO, and you have CO2 here. So that's why here you have CO2 and you have CO. But is this CO that we need? So how do you remove this CO2 here? So to remove this CO2, you just pass it through sodium hydroxide or potassium hydroxide or calcium hydroxide. Those three compounds that I mentioned are used to remove CO2. These three compounds, potassium, calcium, or sodium hydroxide, will remove CO2. So, and it will leave you with CO. It will remain CO, which is what you want. Then number three method is reduction of CO2 to CO using hot coke. You should remember this particular equation in our previous lesson, where I said that the chemical properties of coke. So coke is a reducing agent. So it will reduce CO2 to CO. So is that CO, carbon 2 oxide that you need. So that's how we make carbon 2 oxide, either in the laboratory or in industry. So physical properties of CO: number one, it is colorless, odorless, and tasteless gas. Two, it is slightly lighter than air. Three, it is only insoluble in water. Number four, it is poisonous. Yes, CO, carbon monoxide, is poisonous. It is poisonous because it combines with hemoglobin in the blood. Hemoglobin helps to transport oxygen around the body in the blood. So CO will attack that hemoglobin and attack the oxygen that is attached to the hemoglobin. So there will not be oxygen again that can be transported in the blood, and that leads to what we call suffocation. It leads to suffocation, and that's the poisonous action of CO. And let's talk about chemical properties of CO. Number one, it is a reducing agent. You will see the equation there. Two, CO bonds in limited air with blue flame to give CO2. You see the equation there. Three, CO is a poisonous gas. I've explained that. So test for carbon 2 oxide. So you also see the test there. And lastly, let's talk about trioxocarbonate 4. Trioxocarbonate 4. Trioxocarbonate 4. Let's try trioxocarbonate 4. So triazocarbonate 4, they are salts. They are salts of triazocarbonate 4 acids. Acid rather, sorry. Triazocarbonate 4 are salts of triazocarbonate 4 acid. There are many of them. You have a Na2CO3, K2CO3, ZnCO3, you have PbCO3, MgCO3, CaCO3, Al2CO3, 3. So those are triazocarbonate 4. The preparation of triazocarbonate 4. Now, you need to pay attention here so that you can have a better and clearer understanding. Now, here, preparation of triazocarbonate 4. The first method is, now, there are two things you need to consider when you want to prepare triazocarbonate 4. You consider solubility in water and stability to it. Solubility and stability. Solubility and stability. If a salt is soluble in, if a triazocarbonate 4 salt is soluble, then you prepare it using this equation that I highlight these two equations. You just bubble it. You bubble the carbon 4 oxide into the base. Like here now, this is carbon 4 oxide. Yeah. And then this is the base. You have the base here. This is the base here. So it will give you K2, this K2CO3. So you just bubble carbon dioxide into a solution of the corresponding alkali. It will give you a soluble triazocarbonate 4. Now, generally speaking, only 3 triazocarbonate 4 are soluble. Please take note of this. Only 3 of them are soluble. The first one is K2CO3. K2CO3 is soluble. Na2CO3, that's sodium triazocarbonate 4. The first one is potassium triazocarbonate 4. Then sodium triazocarbonate 4 too. The two of them are soluble. And then the last one, the third one, is ammonium triazocarbonate 4. That one too is soluble. So then let's go on. Let's go on. Yeah. Industrial preparation, sodium triazol. Okay, don't worry about that. Number 2, survey processes. You will treat down one in SS3. It's on the high side. Let's go to number 3 here now. Insoluble triazocarbonate 4. In number 1, I said soluble triazocarbonate 4. This number 1 here. Soluble triazocarbonate 4. How you prepare it now? Now let's now go to number 3. Insoluble triazocarbonate 4. An example of them, I list them here: CaCO3, MgCO3, ZnCO3, FeCO3, PbCO3, CuCO3, Ag2CO3. So all of them, they are insoluble. So you prepare those ones that are not soluble by the method of double decomposition. So you see the equation there. Double decomposition, to explain double decomposition, is like use one radical to replace another radical. Use one radical to replace another radical. So, but don't worry about the principle. Just look at the equation there. So I know that is double decomposition. So let's talk about the properties of thiazocarbonate 4. Solubility now, that's number one. Solubility. I told you those ones that are soluble. K2CO3 is soluble. Na2CO3 is soluble. So you see solubility there. So the rest, all others, they are not soluble. Number two, stability to heat. Now, interestingly, those ones that are soluble are not stable to heat. I repeat, soluble thiazocarbonate 4 are not sorry, there is a mistake. Let me say it again. Thiazocarbonate 4 that are soluble are also stable to heat. They are stable to heat. They are soluble, they are stable. They are soluble, they are stable. Soluble in water, stable to heat. That means that no matter the amount of temperature you subject them to, you cannot break them down. Now, you will now see those ones that are not soluble. They are not stable. That means that they don't dissolve in water, but when you put heat, when you subject them to high temperature, they will break. They will break. Example is calcium carbonate. Now, look at sorry, come back here now. Okay, look at the equation now. This is the equation here. This is the equation. Calcium carbonate. It will break to CaO plus CO2. So that's the equation. And then number 3, all thiazocarbonate 4, all of them, either soluble or insoluble, either stable or unstable, all of them will react with dilute acid. Look at the equation here now. See this equation here. All of them will react with dilute acid to produce carbon dioxide. This carbon dioxide here. And then also produce water. And we also produce water. So that's about properties of thiazocarbonate 4. The use of thiazocarbonate 4 salt, you see the uses there. And then with that, we come to the end of the lecture today. We have done the summary of everything we have done for week 5, week 6, week 7, which is carbon and the compounds of carbon. Thank you very much. I wish you the very best.